Okay, yes.
So will we have to remember, like, from yesterday, all of these?
Okay, binomial expansion. Okay, I had you guys yesterday at the end look at the first example and think about it, right? Do we really want to do x plus y to the 6th? Or you have 6 sets of parentheses, so you're doing what? 3 sets of FOIL to begin with, and then still multiplying 3 more times, right? And so we're going to use something called Pascal's triangle. So the idea is Pascal's triangle is right here, okay? I have it, this is just where I chose to put it because I ran out of room up here to have a decent sized Pascal's triangle. But the idea of Pascal's triangle is that each number in the row is the sum of the 2 numbers above it. So like this 7 here comes from 6 plus 1. Whoops. 21 comes from 15 plus 6. 35 comes from 20 plus 15. So could you continue this triangle in a necessary situation?
Yes.
Yeah, you could. Okay. Okay. With that in mind, okay, I've given you the first 7 rows, which should be what you need there. Okay. Now, the idea here is binomial expansion. Okay, so the expansion contains n plus 1 terms, because if we're raising something to the 6th, that means there's actually going to be 7 terms when we multiply this out. Kind of like when we raise something to the 2nd. When we FOIL something, we actually end up with 3 terms. Okay? The coefficients of each terms are the numbers from the nth row of Pascal's triangle. So when we get ready to do this example here, this is a power of 6. We're going to use row 6 of Pascal's triangle. Okay? The exponent of the first term of A is going to start off as n and decreases by 1 in each successive term. The exponent of B is 0 and increases by 1 in each successive term. Okay? So we're going to be looking at our exponents. With the x, we're going to start high. So we're going to start at 6, work our way down to 0. With what's here in the second spot, so in our case y, we're going to do just the opposite. We're going to start low. We're going to start at 0 and work our way up to 6. Okay? And then, let's see, what is 5? The sum of the exponents in any term is n. And so that's just the idea that we're going to have x and y here in our example, and this is the example here. But let's see if I pick the 4th term. This would be like doing x plus y to the 4th, x to the 3rd, y to the 1st, 3 plus 1 is 4, x to the 2nd, y to the 2nd, 2 plus 2 is 4. So the idea that in each term, our exponents always add to be that power, that n value, okay? So all based on this right here, a plus b to the n. Now, I can explain this all I want, but until I do an example, it's not going to click with me. So let's just jump into our example. X plus y to the 6th. This is power 6. So what row of Pascal's triangle are we using? We're going to use row 6. So what we're going to do, because it's row 6, I'm going to take this row right here, the 1, 6, 15, 20, 15, 6, 1. Each of those numbers represents a term. We're going to write those out. Now, I'm going to space them out because I need room to put stuff in between them. Okay, so I kind of end up, if you look at my notes, I end up using like the whole width of my paper to make this happen. Okay, so I give myself space. So I'm going to start over here at the left, and we've got 1, 6, 15, 20, 15, 6, and 1. And if that triangle wasn't there, I'd probably space them out even more. Okay? So that's because it's row 6. Now, let me change colors here. So now we're going to use whatever's in the A position. In this case, X is in that first position, okay, that A position. We're going to take whatever's in that first position. This time it's X. We're going to start at our highest exponent. What's our highest exponent? Highest exponent is going to be 6. And we're going to work our way down. So each of these spots gets a term. So with the 1, we're going to put in x to the 6th. Then count down. With the 6 is going to be x to the 5th. With 15, x to the 4th. 20x to the 3rd. 15x to the 2nd. 6x to the 1st. And 1x to the 0. So you should always, you start at your power and you always end at 0. Okay, and we'll come back and clean up a little bit of this here in a moment. I'm going to change colors again. Now we're looking at our b value. So what's in the second part of the parentheses? And we're going to do this just the opposite. Okay? If we ended at 0 here, we're going to start this one with 0. So we're going to go the opposite direction. So we're going to start here with, it's 1, x to the 6, and now I'm going to tag on a y to the 0. We have 6, x to the 5th, and I'm going to tag on y to the 1st. X to the 4th, y to the 2nd. X to the 3rd, y to the 3rd. Let's see, 3, where am I at? 4. So x to the 2nd, y to the 4th. Now I'm ready for 5. X to the 1st, y to the 5th. And, as expected, I'm ending at y to the 6th. Okay? Now, if you go through and look at each of those powers, each set of powers always adds up to b. In this case, 6, what my power is there. We're done other than cleanup, guys. Now, sometimes there's a lot of cleanup. This one, there's not a ton of cleanup. Oh, I guess I should throw in. What's going to go in between each of these terms?
Plus.
A plus sign, right? Sorry, I kind of overlooked that one. So these are each going to have plus signs. There's no negatives in this problem to worry about, so you're just going to have plus signs. My job here is to clean up. There's really only about one thing that can clean up in all of this. Okay? When we look at x's and y's, what do you know about something raised to the 0 power?
It's just that number.
So-
It's 0.
X is 0 and y to 0. Something raised to 0 power is, by definition, 1. Remember that? By definition, 1. Your calculator would tell you that. If you enter 5 to the 0 in your calculator, it's going to tell you it's 1. So do I need to write y to the 0 and x to the 0? No. The only other thing I can really clean up, x to the 1st and y to the 1st. Do I have to write the powers of 1? No. So my cleaned up version. Oh, and do I have to write coefficients of 1? No. So this first term, 1, x to the 6, y to 0, can be cleaned up to just be x to the 6th plus 6x to the 5th, y. These next few you just write as is, plus 15x to the 4th, y to the 2nd, plus 20x to the 3rd, y to the 3rd, plus 15, x to the 2nd, y to the 4th, plus 6x to the 1st, y to the 5th. I'm going to say 6x, y to the 5th. And what's this last term? Yeah, I don't need to write a 1. X to 0 is just 1. So it's just y to the 6th.
Imagine typing that in solid.
And I don't remember exactly. Okay, several things here. Unfortunately, yes, you are going to have to type some of these into Savas. Be very careful, right? Watch for careless mistakes. Yes, triangle will be provided. I won't make you create the triangle just because if you have to create this triangle, that's where mistakes can happen also. So I'm trying to set you up for success here. Triangle will be provided. Okay. And I just put this one triangle here mainly because I ran out of room up here and trying to give us room. So this is the same triangle that applies to every single problem, right? Every single binomial expansion problem you do, this is a triangle we're going to use. Okay. Ready to try the next one? Okay. We've got 2 more of these. Then you've got your own time to work. Should have work time then, right? The first one usually takes the longest. That's usually my thought. Okay. You guys have the triangle up above you here. This one, x minus 3 to the 4th. What row?
4.
Row 4, yes? So this tells me row 4. You have your triangle up above, yes? Grab those numbers from row 4, space them out. What's row 4? 1, 4, 6, 4, 1? Do I have to space them out that much? No, but I'd prefer to have extra space than run out of space personally. So now, what's my A value? When I talk about the A value, what's the first piece in the parenthesis? X. What am I going to do with X?
X to the 4.
Okay, in the first spot, start high. X to the 4th. From there, count down, yes? So x to the 3rd, x to the 2nd, x to the 1st, x to the 0. Feel confident I did it right? I did it 0. Now, reverse. There's something different about this one, isn't there? What is my B value?
-3.
You need to consider this a -3. This is where we take into effect that this is a minus in this problem. Is we take that negative with the 3 and think of it as a -3. Okay, so in this first spot, this is going to be -3 to the, not 4th?
0.
0. We're going to start the opposite way. -3 to the 1st. -3 to the 2nd. -3 to the 3rd. And -3 to the 4th. I'm confident I did this right because I ended at 4. And what do each set of exponents add up to be? How about 4 in this case? Okay. Now, by default, what goes in the middle of each problem? These are automatically plus signs because I dealt with that negative, didn't I? I already dealt with that minus sign. So these are automatically plus signs that go in here. Okay, clean up. First term.
X to the 4th.
I don't need to write the 1. And anything raised to the power of 0 is 1. So we just have x to the 4th. Okay. Now, a little bit of thinking here. 4 times x to the 3rd times -3 to the 1st. What would you say that is going to be?
4x to the 3rd.
Not plus. No. This is all one term here that is being multiplied together.
-12 x to the 3rd.
Yeah. So that 4 is a whole number 4. -3 to the 1st is just -3, yes? 4 times -3, not positive 12, but -12. And I'm just I'm looking down and realizing I wrote an extra line of work in mine. And maybe I should do that. X to the 4th isn't going to change. I mean, so this was x to the 4th times 1, which is just going to be x to the 4th, yes? On this one, you're going to be doing 4x to the 3rd times, what is -3 to the 1st? That's just -3, yes? So then if you look at that, 4x times negative 3. 4x times negative 3 is going to be what? Negative 12x to the third. Are you with me there? Okay. So think about this next one. We've got 6x squared. What about negative 3 squared? It's 9, yes? Negative 3 times negative 3 is 9. What is 6x squared times 9 going to be? 54x squared. Are we good now? Okay. Plus 4x to the first is 4x times, I hear the calculator's coming out. What is negative 3 to the third? Negative 3 times negative 3 is 9, times another negative 3 is negative 27. So what is 4x times negative 27?
Negative 108.
Minus 108, and then x. And lastly, 1 is 1. X to the 0 is
Nothing.
1. Negative 3 to the fourth.
81.
Right? Negative 3 times negative 3 is 9. 9 times 9 is how I do it. 81. And that is a positive 81, yes? In your calculator, random comment, if you did negative 3 to the fourth, you got 81. That's what I want. If you did negative 3 to the fourth like that, what'd you get? You got negative 81, which is not what we want. So just kind of beware there. Don't make calculator mistakes. Okay. Notice, what did my signs end up doing? My signs ended up alternating, right? Okay. And that will be typical of a problem that has a minus in the middle. The signs will end up bouncing back and forth. Okay? Gaining more confidence? Okay. One more. 2c plus d raised to the fifth. What can you tell me? Okay. I have a power of 5, so I need row 5. You have your triangle, yes? Grab row 5. One, 5, 10, 10, 5, 1. Okay. Now what? Okay. What do we do with 2c? Start high and end low. So this is going to be 2c to the fifth. 2c to the fourth. Notice I'm putting 2c in parentheses. 2c to the third. 2c to the second. 2c to the first. And 2c to the 0. Okay, now what? Okay, so it's a positive, it's a plus d, so we're just using d. We're going to do just the opposite, yes? So now, this is going to be d to the 0, d to the first, d to the second, d to the third, d to the fourth, d to the fifth. I ended at 5, that's a good sign. Each of my pairs of exponents in this case had to be 5, that overall exponent. I don't know if you want to put the plus signs in right now or not, but at some point you have to Realize there's plus signs in here. Okay. Cleanup time. 1, 2c to the 5th, and d to the 0. Did you say the whole thing? It's not 2c to the 5th.
That would be 32C.
This whole 2c has to be raised to the 5th power. Okay, so we're taking that 2 and raising it to the 5th. And 2 to the 5th is going to be 32. And we're also doing c to the 5th. So 32c to the 5th. What about d to the 0? It's a 1 officially, right? Which we don't need to write. So this term is just going to be 32c to the 5th. Okay, next one. We have 5.
21.
We have 2c raised to the 4th. What is 2 to the 4th? 16. So this is going to be 2c to the 4th is going to be 16c to the 4th. And we have times d to the 1st. You did. I was really struggling with where you came up with 21.
80C to the 4D.
Multiply all three pieces together. 5 times 16 is 80. So 80, c to the 4th, d. Catching on? Okay. Next one. I have 10. What do we know about 2c raised to the 3rd?
What? 8. No, it's 8.
I like 8. 8c to the 3rd times d to the 2nd. And so, put this together and we have 80c to the 3rd, d to the 2nd. Okay, keep going. The number's getting smaller now. We have a 10. What is 2c raised to the 2nd? Okay, 2 squared is 4, so 4c to the 2nd. N times the d to the 3rd. This is going to make 40c to the 2nd, d to the 3rd. Next, what is 2c to the 1st? 2c. So this one's just going to be 5 times 2c times d to the 4th, which is 10c d to the 4th. And the 1 is 1. 2c to the 0, anything raised to 0 is 1. So we just end up with d to the 5th. Okay, guys. I threw an example with a negative in there. I threw an example with where the variable has a coefficient. Those are some of the tricks you're going to run into. Okay. So you have some work time, as I thought you would, but I was afraid to say. Use it, right? So this will be lesson 3.3. Lesson 3.3 was assigned yesterday. It was out there. It is due tomorrow. Okay? So work to get it done. Use this time wisely.